What's up? Welcome back to another episode of Advent of Code 2019, and today we are working on the day 10. And day 10 is all about the monitoring station, which means there is... we want to build a monitoring station. We have a lot of asteroids around, and we want to find the best place to put this monitoring station. And the best place is when we can detect a large number of asteroids. Actually, when we can detect the largest number of other asteroids. So yeah, for example, if you are here, you can only detect this one because this one and this one is blocked by in the line of sight, it's blocked by this other one. So yeah, we just need to find for each asteroid the number of asteroids it can detect. And that will be it. And the trick is that the trick that I want to do, let's just start coding a bit and then I will explain a bit more. That's going to be a bit simpler. So first of all, what I'm going to do is I am going to take the smallest example and we're going to work with that. So I've already started this repl.it where I'm going to write the input that I've just copied from there. So what we do first is we're gonna go through each of those, but beforehand I think we want to actually split the input with line return, and that's it, I guess. Yep. So now input, we want to map it. We want the row and the position y. And there for the row, let's call this a row actually. Oh yeah, I know, here we want to map over all of these elements. So what we're gonna do is we're gonna have to map here, and we're gonna do this, which is gonna split each line into an array of character. So that's gonna be better, easier to handle here. So here we want the character and we want the position X. I think I should remove this auto-completion here. Like, is there like a quick way to do that? Yeah, I'm gonna disable the intelligence. Did that work? I think that worked. Because yeah, it's too much autocomplete for this screen. Let's go with that. So here what we want to do, so yeah, I didn't say what I want to do, but because we have all of this big array, we want to simplify this into just a list of stars, a list of asteroids. Let's call them stars actually. So the stars, and here if the character is hash, this is an asteroid. Let's take the right term. This is an asteroid, yeah. So the asteroids, we push a new object, which is going to be X and Y. That should be it. So this is going to construct a new object with X is equal to this X and Y is equal to this Y. Let's go ahead and console log the asteroids, because we like to do things incrementally. So yep, it looks like we've got X1. Oh, I'm moving things around, sorry. On the first line, 0, 0, we have 1 and 4. So 0, 1, 2, 3, 4. So this is doing good. So we're gonna assume this is good. Actually, there is nothing in the line 1. So yep, we are doing the right thing. So this is not very complex. And for now we need to detect how many asteroids we can detect from 1. So what I think would be best here to make this reusable, because we know that there is a second part here, what I think would be best is to create a function get visible from a position, and we want asteroids. And this is going to return all of the visible asteroids from this specific position. Okay. And by the way, No, I think that's good. I think that's good. So then the next thing we want to do is to go through all of the asteroids. Map. And so we have one asteroid. And we want to detect, let's just console log for now. Get visible. From this asteroid, we want to detect all of the other asteroids that are visible. That's it. That's the idea. And of course, for now, it's doing nothing. It's just printing all of this empty arrays, and this is where the complex stuff is going to happen. So what we want to do is to go through all of the asteroids and check if they are visible. And this is where things are getting a bit more complex. And what I was imagining was to create an array. So first of all, we need to go through all of the asteroids. So same here, we're just going to call this asteroid. We can remove this. And first of all, we want to, let's go with that. So we want to check the difference in x and the delta, so the delta in x between, so let's say we want to check these two. Actually, let's start by creating a function distance between a and b, because we want to use that most likely at one point. So we are going to use the function mat_ipot that is going to just help us a little bit here. b.y. So this is helping us because this is doing this squared plus this squared, and it is doing the square root of the result. So ipot is really great for this case, for the distance in a 2D space. So yeah, I'm using it because this is part of JavaScript library, so why not? Here, so what I was saying is that we want the delta in x and the delta is y in y. So here this is position x minus asteroid x, position y minus asteroid y. And here we want, so one thing you could say is, do we want this as an absolute value? Do we want asteroid x minus position x, or the opposite? I think it's okay, and I think we don't want an absolute value for that. And the reason is, here we want to see this object, and if there is an object that is okay, let's take actually let's make a 3x3 example. So here this is where we are, and if we see an object here and an object here, they should be in two different visible slots. So what we want to do is to sort all of this, to group them. So let's call this groups, and we want to group them by one line of sight. Sorry. So what we want to do is to check, so groups. The idea is we're going to do something like groups dy dx dot push this asteroid. This is the idea. So this is, we don't have like the right data structure here to do this specific thing, but the idea is that then in groups dy dx we are gonna have exactly what we need, which is a list of asteroids that are in the same line of sight. And this is really this is the key of solving this in an efficient way, because we are able to go in this get visible function. We are just doing a linear pass through all of the asteroids. So this is really, I think this is good enough for this challenge. But then here you're gonna say, yeah, but dx dy is gonna be different for each asteroid, and you're right. So what we want to do is to normalize that. I think the best way to do that is to get the GCD of those two and to divide those two by the GCD. This is going to be super helpful for us. So we're going to compute the GCD. So the idea is that we're going to do this const GCD. Oh no, let's call it ratio GCD between dx and dy, and then how do we do that? Yeah, something like that, I believe. Then here we're gonna have dx divided by ratio and dy divided by ratio and dx divided by ratio. I think this is the right idea. But here, like, I'm going in a lot of ideas. Now we need to make this a reality. So let's take the GCD between A and B. So first of all, A and B could be lower than 0. So we're gonna do, we're gonna fix that. A math.apps A and B math.apps B, because we need to just like get rid of this thing. So we do that at the beginning so that it's outside of our heads. And then the GCD is going to be interesting. I'm going to take a second to look at how we do that. Okay, so this is very simple, but I found two places and I want to mix and match those two. So yeah, I have a solution here in Wikipedia that I really like, because this is an iterative solution. I don't think we should try a recursive solution. I think iterative is good. And I have another, the definition here of the Euclid's algorithm, which is something that we might want to use. So we are going to go with those two. So I think this is really good to start with that, which is, yep. Here, to check if B is more than A, we just swap things. So I like to call the variable t, let t equal A. Let's call it TMP to make this code a bit our code. So if A is bigger than B, so A should always be the biggest. So if this is not the case, we want to swap those two. We store the variable A into temp, B into A, and temp into B. That's it. And then here the loop starts. I'm gonna just do an infinite for loop. Oops, an infinite for loop. And what do? Should we do this one or the other one here? I think we're just gonna go with this one. Okay, that's a bit of copy pasting from Wikipedia. That's quite typical for a software engineer. To be honest, the GCD is quite basic, so this is not something that has like a lot of complexities in this. So if B is equal to 0, we return A. If A is equal to 0, we return B, and then we here we do A is equal to A modulo B, and B is equal to B modulo A. Yeah, so that should be good. Let's see again. Yeah, this is exactly this code that we took. So we've got something good. Let's try to do a couple of GCDs just to make sure like we have the right thing. We do like some kind of an assertion test. GCD of whatever, and 0 should be equals to whatever. This is in the definition here. And yep. What else? GCD of this and this should be equal to this as well, right? Let's just try that. Cannot read not a number of undefined. This is good. We've got some problems in our code. Line 31. Let's see. Line 31. not a number. Map asteroid. Get visible and map here. So let's see, let's just console log. Let's console log asteroids here just to make sure like we didn't do any weird stuff. Because this is an array, so this should be good. And here if we console log asteroid, it happens some small issues. Okay. Let's comment that just to, oh, I think this is this line that it's just messing with me. Okay, so you can uncomment that. And the main idea is that this is working fine, true. So of course, like the best way to test that is to make a lot more tests and to store that in a specific test file. But here we're okay with going a bit the short way. We actually did a shortcut by using a Stack Overflow copy paste, but we're gonna just compress this function because we don't care about the code. We know this is working. We're gonna compress this function as well, and we can focus now on the get visible part. So we know the ratio is in a good shape. Now we need to do the groups. So because we want to do this, we need to make sure this is defined. So if this is not defined, then we want to define it by storing it as an object. And then if this is not defined, we want to define it by creating an array, and then and only then we can push the asteroid in this object. Now we're gonna just console log the groups. This is big, and we have some nans, which is exactly not cool. How can we find that? Maybe console log the ratio here. dx dy ratio. Let's try that. Oh, I think we should clear this output between each execution to make sure like we have the right and clean output. Okay, actually there's one thing that we don't want is to divide by 0. And divided by ratio, we divide by 0. And the param here is if dx is equal to 0 and dy is equal to 0, we should just stop this function because we are comparing the same position, and the position is the same as the asteroid. So this is a problem, and we just want to not take into account the same asteroid that we are on. So if we run that again, let's just clear that and run that again. And we can also, yeah, never mind, let's focus. We can remove this console log for now to keep things legible, readable. Okay, so there is a lot of stuff happening. The problem is that I didn't do a good output. So I want to do json.stringify here so that we can really read that clearly. So I don't have a bug for now, but I'm still like behaving like I had a bug because I want to make sure we just have the right data. How can I make sure we have the right data with this output? So 0 minus 1. I think the only way is to go through. Actually, I cannot really do that. So now we know that we grouped the asteroids by line of sight, and we just need to take the asteroid that is the closest to us. And in order to do that, I think what I'm going to do is I'm going to do that. Asteroid and distance between, just let's call it D, and this is distance. Let's go and add a line return to make this more readable. distance between position and asteroid. And what I said is that we want for each group the first asteroid. For each line of sight, we want the first asteroid in the line of sight. So how we do that is we're going to have to iterate through all of these. And object.values is going to be super useful because we don't care about dx divided by ratio. We don't care about, sorry, dy divided by ratio or dx divided by ratio. We just care about all of these arrays. Map. We have another group. And we want to object.values of group, and we map that again, and we have a list of asteroids here. And what we do now is we want to sort this list. So list.sort. Why are we doing that? Because we want the closest asteroid, so we just sort that between A and B. We want the shortest, so we A.distance minus B.distance, and that's it. We want the first one. So const list visible list. We just have to add that, push this, and that's it. Here we can return a visible list, and now the debug shall begin. Let's clear here and run that. Okay, so we have a lot of console logs. Where are they coming from? They're coming from here. Let's go back to the problem statement, and we want to detect the largest number of other asteroids. So we don't really care about the asteroid themselves, we just care about the largest amount of asteroids. So what I would do is return the asteroid itself, and then the visible, which is get visible.length. And then this is const result, and we want result that we want the largest one, so we can sort that right away. Sort a b dot visible minus a dot visible, and then we can console log result of 0. Let's see. So much code, so little debugging. So here, what is the best one? Best one is 8 visible asteroids at the position 3, 4. Okay, so that's really good. Let's throw a bit of confettis, if I can, actually. Huh. Never mind. Yep, I'm just really happy. And the next step, as you know, we've been doing that for a couple of days now. So you know that next step, once one test case is passing, is we want to run that on all test cases. 5833. 5833, this is really good. So just as a reminder, here I'm outputting the coordinates of the asteroids plus the number of visible asteroids from this asteroid. And then I am sorting to sort by the highest of visible asteroids to the lowest of visible asteroids, and just taking the first one. So this first one is the maximum number of visible asteroids. Let's just go and continue this one. We want to continue because we want to test and make sure there isn't an edge case that we missed. 1, 2, 35. 1, 2, 35, this is looking really good. Okay, let's run that. 6341, that's really good. I'm happy about that. And 1113 2010 210, sorry. 1113 210, this is good. Let's just go ahead and grab the input puzzle, run it here. Okay. Oh, it took a while, but we've got 22, 28, and 326. Let's see. We want how many other asteroids. Find the best location for a new monitoring station. How many other asteroids can be detected from that location? So we need this number, which is the number of visible asteroids from the location 2228. Let's submit. Oh yes! Oh yes! We've got that right. Feels good. Oh yeah, a bit of confetti. I was trying to trigger them earlier. Okay, we are now back to day 10, part 2. And here, what do we need to do? There are too many asteroids. So we set up our monitoring station, but there are too many asteroids. Okay, so we complete vaporization by a giant laser. Oh, that's fancy. Fortunately, in addition to an asteroid scanner, the new monitoring station also comes equipped with the giant rotating laser, perfect for vaporizing asteroids. The laser starts by pointing up and always rotate clockwise, vaporizing any asteroids it hits. If multiple asteroids are exactly in line with the station, so the laser only has enough power to vaporize one of them before. Okay, so this is going to be really interesting. So really interesting. Okay, so here we know the position of the monitoring station. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so this is interesting. Some asteroids, the one behind the asteroid market 1, 5, 7, don't have the chance to be vaporized until the next full rotation. Okay. Okay, so that's good. Next 9 to be vaporized as 10. Finally, the laser completes its first full rotation. A second rotation, vaporize the last asteroid. Okay. The elves are placing bets on which will be the 200 asteroids to be vaporized. Win the bet by determining which asteroids that will be. What do you get if you multiply x by 100 and add y? Okay, so this is what we're gonna do. We want to win the bet. And we've got the test case here. Let's just copy paste that and work on this test case. So here we are creating the asteroids. Let's get this array of asteroids closer, because these are helper function, which is really good. Here we are just handling the input, else if char is equal to x, let position, and here we just store position is equal to x and y. And this is it. We've got the position of our asteroids. Yep. Let's just solve one. Just write function solve one. So that we can write function solve 2. Hopefully the code won't be too different. Here we can call solve2. Okay, so here what's a bit different from the previous part is that we cannot just actually we could reuse the getVisible function. But now what will matter is the dx and dy. We might want to give this in a specific order. Sorry, here we might want to push invisible list in a specific order so that we've got the right thing in the end. So we don't want to modify anything in the function except this should be in the right order. How do we do that? And the order should be so x and y are going down, so it should be from at the beginning it should be dx equals 0 to the max, and then from the mean to 0 again. What? That's gonna be interesting. Yeah, so here that's where things are going a bit difficult for me, because I've chosen a specific way to do the getVisible, and here I am trying to just order this, and this is not going to be super easy. Yeah, so that's the main idea. I think I'm going to have to do some tips and tricks. And once we have that, I think we need to do this kind of sorting. So meaning first there are the dx that is very low, and then the dx that is in that way. I mean, we just need to sort dx in that way, and then we need to sort dy in a similar way. Dy, it starts with something small and big, and then big and small. This is not easy. So I don't know exactly how we can sort that. I think we're gonna have to go with the angle. We're gonna have to compute the, I think that's gonna be the easiest, right? We're gonna have to take this dx and dy and get the angle, and then we do the sorting like this. And we just have to sort this specific list, I believe. So here we sort visible list. This is it. This is how we're gonna do it. First of all, let's do visible, that's sort, and then we have A and B, and then we need something like A dot angle minus B dot angle. That's gonna be tough. How do we get the angle? So this is gonna go, we're gonna get back to trigonometry, if this is the right word in English, which is, yeah, just finding an angle with two numbers. Yep. So get angle from 2 points. I think this is tangent. finding the angles between 2 points. Yeah, that's some kind of stuff like that. Arctangent, this is atan 2, which is the right stuff. That's we're gonna need. Okay, so this is really good. This is exactly what we want. Okay. So arctangent 2, is that the thing? From 2 argument arctangent, this is it. And I think this, oh, I cannot select that. Okay, atan 2 is available in JavaScript. So math.atan2, let's just actually go in the JavaScript thing to understand what's happening here. So, because here what we need to see is what is the numeric value that it returns. So between minus p and p. So let's see. Oh, that's going to be tough, because we're going to have to switch that to, I think actually we don't care about switching that between radians and degree. We can keep between minus p and p, but we are going to need to make a change because the 0 is not here. The 0 is here, and then it's rotating in the other way. Ho, 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 ho. Okay. Okay, so let's do that. So here we care about, let's create a function actually. Function get angle, position. Actually, it's dx and dy. Position asteroid. That's gonna be how we do it. So here, get angle A minus get angle B. That's getting really interesting. Actually, this is not that way. We need position and the asteroid. So this is position A minus, let me do a line return here to make this more readable, and position B. So how we do that is we do, so we return something like math@2. So we have 2 points here. So what we need to do is to get asteroid.x minus position.x, I believe. Is that it? Because we need to do that. It's just one x and one y. Maybe here they explain it to us. Nope. So if we have 2 points, yeah, I think that's correct. And is that x and y? Y and x, that's very important. That's the kind of stuff that's really important. So here this is y, and here this is x, and this is giving us something between minus p and p. Let's see here. So this is this one. So let's just try actually. Let's just try in the repl.it here. Math.atan2. If y is equal to 0 and x is equals to 1. This is 0. Okay. Now, so I try the point that is here. Now we try a point that is here. So x 0, y 1. Okay, so we have p divided by 2 here. And here, let's see just these points. Actually, we don't care. Let's see these points. So -1 for y and 0. Okay. So we've got all of the information. So this is 0. This is p divided by 2, and this is minus p divided by 2, and this is either minus p or p. Now we need to get a number between 0 and p. I think that's the best. So what we're going to do is we're going to add p to that, and then we're just gonna add p. Let's just add p to see what happens. Plus math.pi, sorry. 0, 1, 1, 0, and -1, 0. Okay. So now we have something. But it's going, I think actually we don't really care exactly to understand what's happening, but it's going in the wrong order. Because it's going in that direction. And on our end, from what I understood, the laser is going from the top, it's going in this direction. So we need to change that. We need to minus at the beginning. Minus all of these. All of this. Oops, sorry. Okay, so we need minus this plus math.pi. Okay, so this is getting interesting. We are getting closer, but not there yet. So as always, we are seeing what happens when this is 0, 1, 0, minus 1, 1, 0, and minus 1, 0. Ha! And what we care about now let's just make this a positive number, because otherwise it's going to be confusing. So math.pi times 2. Okay, so that's going to be better. I'm doing some stuff and I need to get this right now. So what we want is the point. Oh, wait. I might have done a mistake. Because here, like I made a mistake. Sorry, this is okay. This is okay. Because the problem is that here we are going in this direction, but because the y-axis is going to the top. So here this is y equal 1, so we're going in this direction, but in our case y equals 1 is here, so we are going in the same direction. So everything is good with this function. We shouldn't make this negative. However, what we should do is making it start at the right position. So it should be equal to 0 when we have minus 1, 0. I think this is it. I think this is where it should be equal to 0. Let's let's try to understand. So here, this should be the smallest value at the top. So if we have a point here compared to the position, this should be the smallest point. Let's see for a point here. Oops. Let's see for this asteroid what it would do. This is above that. That's good. Then an asteroid that is here, that will be here, would be 0 and 1. It is even higher, so that's good. Let's see an asteroid that is here. So this is this and minus 1. This is even higher, so actually this is good. Let's see an asteroid that is around here. It should be even higher. Minus 2 and minus 2. I think that's it. Yes. Ah, it's smaller. Not good. Okay, because I did math.py. Let me take a second to understand like this angle thing, and I will get back to you. Okay, so what I was thinking is that here, this was when you have this point, this was math.attend2 was giving 0. Then when you were going in this direction, it was increasing into p, and when you are going in this direction, it was decreasing to minus p. So what I've done, when I add plus math p, I'm saying this is 0. What I was thinking is just if I add 3/4 of p, it should be the right thing. Let's try that. This is math. 3 times 4, no, 3 divided by 4 times math p. This is giving 0 for a point that is here. This is not looking good. Let's see. This is minus 2 and 0. I think, you know what? Let's do that. First of all, we had a number that was between minus p and p. So in order to solve that, we're just going to do 2 plus 2 times math.py. And I'm sorry. Actually, you know what? I'm going to copy paste that here so that it's easier to deal with it. And modulo 2 times math.py. Let's actually do that for several numbers. So this, we're going to write everything here. So 0 minus 1 should be this point here. No. Minus 1, 0 should be the shortest. Then 0, 1 should be a bit more than that. 0, 1 should be a bit more than that, and then 0 minus 1 should be a bit more than that. So what we're creating here is just, and then minus 2 should be in between, and then here minus 1 should be in between. Okay. Oh, what happened here? Everything refreshed. Okay, so here what we want to do is, oh, I made a mistake here, made a boo-boo, unexpected identifier. What if I do that? Oh, I forgot parentheses here. That's it. Yes, that's looking better. Let's clear that. And okay, so here, for example, we know that this should be an increasing numbers. Oh wait, here this should be. If we have an asteroid here, it's approximately -1, 1. Okay. So here we just created a list, some kind of a test case, and we know that this should always be increasing numbers. And actually here, instead of all this stuff, I should use get angle. My bad. We take the time to do the right thing. It's going to be helpful in the end. So position, oh, that's okay. Okay, so we have a number and we need to switch that up. So we should do something like -p divided by 2. Let's try that. Minus math.pi divided by 2. What if we do that here, 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 and here? Minus pi divided by 2. Let's try that. We clear this and we write that. This did not work. Okay, so we copy paste that at the end. So yeah, I'm just struggling to offset this origin here. Actually, I don't have to console log because it's confusing for the... Oh! Yeah, here you see, because of my console log, I was doing something bad. So here, I'm just gonna use that again. It should be better. Let's try to add p divided by 2. I'm just now I'm kind of giving up a little bit and I'm just trying stuff, and we are not doing the right thing here. So maybe we need to add stuff in here. Oh, looks like we've got it. So that was it. That we wanted all of these numbers to be in an increasing order, and this is what happened. So this is our solution. It was not pretty, to do all of this fiddling around. But yeah, sometimes you gotta do what you gotta do. So this is this plus 2 times math.pi in order to make sure the number is positive, plus math.pi divided by 2 in order to shift number to the right origin, and then modulo 2 times math.pi. It should be it. It should be it. So now we can go and do, yeah, this should be it. So the visible list should be sorted in the right way. Now what I would like to do is to do get visible the position. From the position we have all the asteroids, and yep, I think if we console log that, so we have x8, y0. Oh, did I make a mistake? x8. Oh, no. So this is complex. x8, y0. So x0, 2, 3, 4, 5, 6, 7, 8. So this is the first one that is visible. Let's actually look in here because that's gonna be helpful. So no, y should be equals to 1. So this is not correct. So we have a bug, and we're gonna have to find what this bug is about. So let's see. First of all, we should only see visible stuff here. And here there are far too many asteroids that are displayed. So this is a major issue, and this is most likely the problem in here. So let's read again get visible and understand why it was working in the previous challenge and it's not working now. So here I just want to make sure we are going through this function. This is a bit silly, but yeah, of course we are going through this function. So we have position and asteroids. Let's see if what is position. Let's see what is position. That's important. Y3 x8 0 1 2 3 0 1 2 3 4 5 6 7 8. Okay, so this is correct. Now, are the asteroids correct? They should, right? Zero, 1, 0, 6, 7, 8, 9, 10, 15, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 14. So okay, so this is looking good. I just checked the first line and this is looking good. Let's try to roll back by removing this sorting. And we just do get visible once. So we should only, oh wait, let's remove this and run that again. So here we should never see, for example, this one. So 0, 8, we should never see it. let's see. So x equal 8, y equal 0. We don't see this one, right? X equals 8. Okay, so we see it. So there is an issue with our getVisible function. Not sure what is this issue. So. Let's try to log that. So let's try to log as well the asteroids. No, asteroid, sorry. This is where the main issue is coming from. We are just going to find what's up. So here, this is the problem. So this is 0, 3, and we have 3 as the ratio. So because this is 0 and 3, it is going to be stored in the position. Actually, let's show the position as well. The x and the y. Let's clear and run again. So this number is what we care about because we know this asteroid is here especially, and we know that this asteroid should hide it. So we want to follow this specific asteroid. So this is 0, 3. The ratio is 3, so we know it's going to be stored in 0, 1. I mean in 1, 0. Now we need to find this other in 1, 0. So this one, 8, 1, this is exactly this asteroid, and it should hide it. So it's this 0 and 1 as well. So this is interesting because everything is computed correctly. Now we should check here console log list. Let's clear that again, run that. Only if no, let's just console log the list. Let's just print L in front of it to make sure we are, just to make sure to understand what debugging we are seeing. Okay, so this is what is of interest for us. Let's move my head here. Okay. So we care about a list. Yeah, this list. This list is what is interesting to us. This should only, can we search in the terminal? No, we cannot search in the terminal. So this number should only be here. So this asteroid should only be here. Yeah, it is only here, right? It is only here. However, for some reason in the end, we have both this one. Oh, we just have the biggest one. What the hell? Let's actually do that first. Const sorted is equals to this. Actually, just by doing this, it is sorting the list. So yeah, this is L2. Let's just write something, and here this is list of 0. This is what we care about. Okay, so let's run again. Let's clear the input and run again. So as you can see, there is a big issue in the sorting function for some reason. It is sorting. Oh my god. Why is it distance and not D? How did that ever work? I'm just super confused. Because we have D here and we had distance here. And this worked. We were super lucky for some reason. Wow. Let's clear that. We had a bug which was just a naming issue. Now if we have 8, this, you can see this is inverting those two elements, which is correct. So we can remove the debugging and we can uncomment this. And if we clear and run that again, it should give us the right stuff in the end. Yes, we have x equal 8, y equal 1, but we don't have another x equal 8, which is good. Whew. Okay, so we solved our issue that for some reason didn't block us in the first part of the challenge. We were super lucky. Now we have those get visible points. So what I wanted to do is const list and then while list.length is below, strictly below 200, then we get more list equals list.concat this. And here, so we need to do let because we are changing list. Okay, so const visible equal this, and then visible for each of those asteroid, we need to remove it from the asteroids. Oh, how do we do that? How do we remove one asteroid? We need to find the index. Find index x. No, whatever. Let's call it a. A.x is equal to asteroid.x. And a.y is equal asteroid.y. This is getting trickier. I can feel like the pressure on this one that was not easy at all. So we've got our asteroids, our index, and now we just need to remove it from the asteroids. Asteroids.splice, and I always forget how to use splice. Okay, splice, when we want to just remove one item, remove one element from index 3. So we have to have the index and then 1. So we were here. And so this is index and 1. This is not going to work. Yes, this is going to work. Okay. I think this should be good. And then we should console log list 199 because this is the 200 minus 1. Const position, it's 200. So let's just use a constant here so we can reuse that in the future maybe. Hey! this is running for a while. Maybe there's a problem in our while actually. Let's cancel log asteroids. And list. Let's stop it, clear everything, and run it again. Okay, as you can see, there is an issue with an infinite loop, because for some reason asteroids is empty at that point in time. So we need to have this, and yeah, but that won't work because this is too small. So yeah, I understand what happened, what's happening. So we need to make sure asteroids that length is more than 0, otherwise of course there will be no visible asteroids. So this is the infinite loop. So we can remove that. Okay, I think we're getting there. Run. Undefined. Yeah, the idea is that there are less than 200 asteroids in here. In the large example above. What is the large example? The one 1113. 1113. Okay, so this is this one that we need to take because the smaller test case was not working for us. So we need to fix and make the we need to fix this input and use the X. Oh, actually, we shouldn't touch that. What we need to do now, in solve one, we need to change the input. That's interesting. Whew. So what we need to do here in position, we need to store, because there will never be an X here. We need to do it ourselves. So with solve one, solve one should also modify the input. And this is tricky, but that's it. This is how it works. So position is equals to result 0. This is it. So this is storing the position in here. However, we have still an asteroid that is at the same position as position. So we need to fix that. Const index equals asteroids find index a. So if a.x equals position.x, so we're doing exactly the same thing that we just did a couple of seconds ago. A.y equals position.y. So this gives us the index, and then we just have to do asteroids that splice index 1. And at that point in time, we have the position with the actual position of the station and the asteroids without the station where we placed it. It's getting complex. So here is the position of the station, and here is the result, which is the 200th asteroid, which is 82. And so in the end here, instead of outputting this, we need to be outputting this dot x or y. 100 times x. So x times 100 plus this time this dot y. This was crazy, but I believe we have reached the end here. And now the next step is to run it in our crazy big input. And we run it now. It's going to take a couple of seconds, I believe, because this is not the best complexity that we had. Maybe there were some interesting tricks to solve that. And we have our solution here. Let's enter it here. Yes! We've got our solution for day 10. Thank you very much for following along, and feel free to drop a like because it helps a ton. Feel free to drop a subscribe, and see you in the next episode. Bye bye.